The 3D water phantoms, it's been on the market about 10 years now. We're actually in our second generation of hardware, and I'll kind of touch on that as I kind of work through the hardware component of the system. But I've got about well over 120, 130 units out in the field, all across the world, U.S., international, just about every continent now has our water phantom in place. But basically, obviously the objectives for water phantom for 3D water phantom, I should say, your acceptance testing, your commissioning of your Linacs. You want to check all your energies, your field sizes, your wedges, etc. You want to check that system versus the manufactured stated specs. You're doing your annuals, for example, your TG142 beam quality checks as well. And then periodic checks of beam quality as needed, say PM of the Linac or any major repair of the Linac, things like that, where you may have to just to check and make sure things are still copacetic with the system. Reasons to bring the water phantom out. Kind of some of our basic specifications for our water phantom. What makes a good water phantom? Obviously, you want highly accurate and repeatable positions. You want to produce high quality raw measurements. Raw measurements of high quality are key to keep you from having to spend time on post scan processing and analysis. The better the raw measurements, the better your time can be used elsewhere. So that's one nice thing about our water phantom is it produces very high quality raw measurements, and really very little post scan processing is necessary. Obviously we have the tools and the metrics that you can look at and see, but there's not a lot of manipulation of the data that has to be done. You want that reliable hardware to be in operation year after year, because again, this is not something that necessarily gets reused every day. Worst case scenario, you may have it quarterly. Best case scenario, you only pull it out once a year for your annuals. There's a lot of different reasons for that, but you want that reliable hardware to be functioning as you pull it out and need it. You want it easy to set up. Since again you're only using it best case scenario on an annual basis, you don't want to have to relearn the system. And I think ours is we kind of took pains to make it user friendly and easy to use, so you don't have to quote unquote relearn the system. Everything is kind of at your fingertips and easy to set up. We've got a system over at the University of Wisconsin, the calibration lab. They use it on their TrueBeam, and quite honestly, the person that is in charge over there using doing the scans and teaching on the scans and things like that can get it set up in about 15 minutes once filled. So it's pretty quick, as far as getting things going for your setup and scanning. And then you of course want that flexibility and compatibility, the ability to use just about any kind of detectors out there. And with ours, you can use conventional ion chambers. It comes with our A28 scanning chambers, our 0.125 scanning chambers, but you can use any host of detectors, farmer chambers if you're doing your monthly your monthly QA. You can use diodes for SRS. We've got our W2 scintillator, which is one of the smallest water equivalent detectors on the market, a 1 millimeter by 1 millimeter detector size and water equivalent. So that's something that's available. You want to be able to kind of handle a bunch of different protocols, whether you're using TRS 398 or using TG 142 or TG 51 or what have you. Those protocols are incorporated into the system as well. Various TPS formats. You want to be able to import into the treatment planning system your scan data and your beam data. So we have functionality to import into most of the major treatment planning systems, and I'll kind of touch on that when I go through the software. But you want that, like I said, good flexibility, good compatibility, and that we offer with our DoseView 3D. So some of our componentry in the hardware, as far as giving you that accurate and consistent positioning, we utilize a heavy gauge extruded aluminum frame. It maximizes rigidity, it simplifies the setup, and it really helps maintain reproducibility. All our positional accuracies are within 0.1 millimeter per axis, so it's a very accurate system. very streamlined. You can utilize it either in step mode or in the continuous mode at your convenience or desire. So, give you functionality that way. It allows for a quick 3-point leveling system, that gives you, and I'll kind of touch on that in a little bit, as far as, the ease of use of our leveling system and getting the chamber alignment set up for, accurate runouts and make sure that everything is level and in alignment correctly. Yeah, even before the system go out the door, every system we have a burn-in period for the motors to make sure that they're functioning correctly. We've got an industrial coordinate system measurement unit in-house that we verify the accuracy of every system before it goes out the door to maintain that 0.1 millimeter accuracy. So it's a very highly accurate system, and we ensure that maintains that accuracy as it goes out the door. So some of our components within the Phantom are designed for ease of use and integrity. So the frame itself is mechanically secured to the water phantom to maintain that long-term robustness and integrity. We have a something small, but it's a nice feature, is that we've got an advanced suction drain. It has a moat system on the base of the water tank that really allows you to pull the vast majority of the water out. So none of the armature or the robot scanning mechanism is sitting in residual water. So it reduces mineralization if you're not using deionized or distilled water. Kind of keeps the system out of any extra water. Something small, but it's a nice detail that we've added to the system. We've got a fully integrated lift and reservoir cart. As you can see here, the reservoir cart has a automated pump system that allows you to fill the tank, and has a precision positioning platform, which I'll touch on the next slide a little bit. Gives you some accurate lock-ins for your rotational needs if you're doing diagonals. We also have an optional lift cart that is lift only with no reservoir, so you can use that as well. But our positioning platform has course rotational adjustment that lock into place at your 45s and your 90s for doing those diagonal scans. We also have fine adjustment levers in the X, Y, and rotational positions. So once you get the course adjustment of the water phantom, you can fine tune that both rotationally and also in the X and Y direction to help you align to your light field and your center crosshair very easily. As kind of mentioned, we're on our new generation of hardware. We've got a little bit lower profile, a little bit smaller footprint of the tank itself, more compact design. It not only improves the rigidity of the system, so you as you're scanning, there's less to no flex of the system at all. So you get very good, again, raw data. You don't have any issues with cantilevering or things like that. It's a very accurate straight scanning system. It, like I said, improves that rigidity, and it also has made it Halcyon compatible. So if you have a Halcyon or an Ethos system from Varian, or you're looking to possibly acquire one, our Water Phantom is compatible with those systems. And you can see that here in this slide here, we show the system in the Halcyon. We have not only our conventional full depth fill lines on the system, but we also have Halcyon fill lines, so you can fill a tank to a certain level to not over burden the couch. We keep it within the couch weight tolerances with our Halcyon fill lines. And then we also offer a brass centroid cap for alignment, utilizing the MV imaging system in the Halcyon. Obviously, you can't really view the leveling system in the halcyon itself, just because of the bore. So you can actually visualize it with that brass cap. So that's something we offer with the halcyon system functionality. We have wireless connectivity. Our pendant, as you see here, it's a full functioning pendant, gives you a wireless connection to the system, so you have freedom to walk around the Phantom and check your levels, check your runouts, make sure that everything is aligned correctly. Don't have to worry about dragging cables around with you on that. It gives you that simple setup. All your directional buttons are there, X, Y, and Z. We got probe speed, things like that. You're always showing your onboard display as far as what your probe position is. You can set your origin right on the pendant as well, and has a three touch button speed modes. You can go for a 0.1 millimeter step mode up to a fast mode for movements through the larger tank to get to your scanning positions quicker. Have a nice feature is a bias switch at the pendant. So if you're for some reason you're out at the console and you forget, you turn everything on, you're ready to scan, but then you realize that something was not quite right. Maybe your reference chamber is out of position. You go back in the bunker and you realize that you left the bias on. You can turn that on and off at the pendant. You don't have to run back out to the console to turn on or off your bias. We also have wired or wireless connectivity directly from the water phantom itself to the PC, so you can actually connect without any kind of serial or Ethernet cable to the PC. If you want, you can go ahead and just do a wireless. We include it's a Zigbee type radio, which allows you to connect from the water phantom itself to the console wirelessly. So that's a nice feature as well. So it gives you that versatility and convenience. Electrometers, one thing that we have a lot of experience in over the years is electrometers from our very early Premier 3000 and our CDX 2000 electrometers up to our tool channel touchscreen Supermax that's available. We've got a lot of experience in electrometers, and we took that experience and built that into our DoseView 3D. It's a charge digitizing electrometer for very high speed acquisition for fast scanning. It's got a 10 femtocoulomb resolution, so it's a very fine resolution. You've got the ability for dual polarity bias voltage, so you can do those plus or minus positive or negative bias polarities as you choose, as you see fit. Then we also have the independent bias voltage. So if you're using, say, a diode for your field scanning, and you're using an ion chamber for your reference detector, you can turn it on and off that bias independently. Obviously, you're not going to put bias on a diode, but you will on the ion chamber, and that has the ability to independently select the bias voltages for the system. I kind of mentioned innovated detector alignment system. So you can see here in the little cartoon drawing, we've got a alignment jig, which gives you kind of a good view of what you're seeing at the surface. You've got the side crosshairs and then the X on the front side, and you can check your levels. If you're too deep or you're too shallow, you're going to see some distortion in that X. If you're at the water level correctly, it shows a nice concise X on the front side there. So it's a good visual adaptation for making sure that you're at the correct level. And as you run out to your extremities of the field sizes you want to scan, you can kind of track that and make sure that the system is staying correct. And then you'll see in the upper right hand is a alignment jig for the ion chamber. Nice thing is you have you've got the line on the buildup cap there to show the point of measurement for the ion chamber. You align that on that jig to the line on the little aluminum block there. Once that's locked into place, you can just swap that out with the water surface alignment jig, and it puts that ion chamber right in the exact position you need it for scanning. So that's a quick and easy swap out to make sure that everything is aligned correctly. So that's the alignment jig for your fast, precise setup. We include a number of different detector holders, for the scanning chambers that we provide, the A28s, but also a universal chamber holder for, say, a farmer chamber or larger volume chambers. Number of different parallel plate chambers, for a roost chamber or a Marcus chamber, etc. So it gives you the functionality there for those parallel plate chambers for electrons, as well as small volume chambers and diodes and things like that. So we also have the ability to custom build and custom make any detector holders, and we probably have already for any number of different manufacturers, chambers and detectors out there. So we've got those available as well. But the system comes with, I think, 9 different detector holders now. So it's all included as one package. So as I mentioned, the water level alignment jig. Not sure why I have that on it twice, but can't say enough about it. The nice feature too in the software to help locate that XY center of and to help you to find the origin, we have a automatically find beam center function, which basically will run that detector out. Once you have your origin set, you can run that detector out to the X and Y extremities of the 50% lines, and it will actually then calculate and tell you any small shifts that might be necessary in the X or Y direction to place that detector in the absolute center of the field. So it's a nice little touch, nice feature within the software. As I mentioned, we include 2 of our X-ray and A28 scanning chambers, 0.125 volume chambers, typical for scanning volumes. It's a spherical collecting volume, so it's nice. And if in the situation where you're doing cross-plane and in-plane scanning, you don't have to worry about any, again, with the raw data, you're going to get equivalent measurements across both axes, so you don't have to do any adjustment or manipulation of the scan data due to having an elliptical collecting volume. Our chambers, not only the A28, but every chamber in the X-ray line is a homogeneous construction with Schanke C552 conductive plastic, and that's for the collector guard and the shell. Low Z material. There's no metal or high Z material in the beam area, so there's no perturbation of the beam. It gives you the ability for us to have a larger guard, so it helps maintain those collecting volumes very, very well. So when you have a collecting volume of 0.125, it's going to maintain that because of that large guard. And then because the construction is a much more robust material in that C552 plastic as compared to, say, a graphite chamber or an acrylic chamber, you'll see that they last much longer. So we can offer a 5-year chamber warranty on all our ion chambers, be it the scanning chambers here or our farmer chambers, the A12 or A19. We offer that 5-year warranty standard, and we do even offer a extended warranty up to 10 years for very, very minimal cost to extend that up to 10 years. And then we again offer any number of different chambers. Like I mentioned, our ion chambers of various collecting volumes, our scanning diodes. We've got both the vertical orientation diode and a horizontal orientation diode, depending on your preference, as well as detector holders for those. And as I mentioned too, our W1 and W2 scintillation detectors for not only point measurement, but also scanning functionality as well. They're water equivalent scintillators, or water equivalent plastic material. It's an organic scintillator, and very small volume, either a 1x1 millimeter scintillator in the W2, or the a 1x3, which is offered for both W1 for point measurement and W2 for scanning. So those are available as well for small field. Versatile serviceability to the system. The nice thing about our system too is that we use redundant motors for the system. We've got 5 motors, so there's no cantilevering, and all those motors are common. So if you do need to replace a motor, you can field service it yourself in house. So basically, it's 4 screws, very easy to swap out. They're self aligning, so they'll kind of mate up with the um, motor across the way if for some reason something like that has to be changed. But our motors, our motion control unit, our cabling, our power supplies, all are user replaceable components. Should there ever be a need to do replacement, it's not something that the system would have to come back in for repair. So I kind of touched on the hardware now. I'm just going to jump into the software. And like I said, this is going to be a kind of a quick overview of the software. So if you want a more in-depth demo, we can certainly do that. But please feel free to contact Standard Imaging directly, and we can set up a personalized web demo for you and your colleagues as you see necessary or that you would like. But anyway, the software. So we kind of rewrote the software basically from the ground up about 3 years ago, and have been adding to it and building upon it since then. We actually had two new releases in 2022, and I'll touch on those as well at the summary. But anyway, it's a very easy left to right, top to bottom navigation, kind of like you're used to with regards to any kind of Windows environment or any kind of browser environment. It's very familiar browser-based kind of functionality in the system. We like to say there's no hidden features. It's kind of everything is right at your fingertips. There's basically, as you can see there, we've got three tabs. We've got the setup tab, the measure tab, and the analysis tab, and that's pretty much it. Once you get into those, everything is kind of at your fingertips. And again, I'll show you that as I kind of run through the software a little bit. So the ScanQ setup, gives you, very easy copy and edit functions and things like that as far as setting up, and it kind of walks you right through it. Same with setting up for the measurement, the hardware, and choosing your scan cues for scanning. And then the analysis page too, very, very simple. Everything is right at your fingertips, and I'll kind of touch on that also. That being said, let's take a look at the software. Let me jump in here. I'll go to my setup page first. So this is kind of where you do just that as your setup. You add your clinics accordingly. As I click on that, I can easily add my clinic. Nothing out of the ordinary there. Your name, location, etc. As I have added my clinic, then I can add my Linacs. You see here, clinic 2 demo. I've got a couple different Linacs. And if I would expand on that, it shows the different energies that I have added. Again, very similarly, you just add your function, walks you right through it. You add your energies, your modality, whether it's photons, electrons, or triple F, what your Dmax is for those particular ones, etc. So that's very easy setup. Same with detectors. You can set up all your different types of detectors. Here I've got an A12, which is our 0.6 cc farmer chamber. We've got our A26, which is a small volume chamber. Our 2 A28s for scanning and reference. And then we also have an A4, which is a spherical chamber, which you can also use as a reference chamber. It sits outside the field if you're doing small field scanning, utilizing something like the A4 for your reference chamber. It does not have to sit in the field, so you're not perturbing or interrupting the beam or covering any of the beam if you're using something like the A4 spherical chamber for a reference. I'm going to jump over scan cues real quick, just to preferences. These are pretty much straightforward to what your CSV output delimiters are, whether comma or semicolon, etc. Your decimal separators, depending on region. Here in the States, we use a period. I know elsewhere, pretty much everywhere else uses comma to separate your decimals, your date formats, your time formats. So you can choose your different ones very easily here. So that's your preferences. But now jump back to scan cues. Very easy to build a scan cue. You'll see here where we have kind of four categories. They're showing what we call, just a not set and showing in gray. As I add things here, you'll see now that's complete, but I can go on doing water. If I'm doing triple F or electrons, you can choose your modality, your field definers, whether it's JAWS or MLCs, your modifiers, whether you're doing wedges or electron cutouts, what have you. So that shows complete now. Go to my energies. I just want to choose 6 MV for this. You can add them very easily as well. So there's my 10 MV. I don't have 10 MV on this Linac, so I don't need that, so I can get rid of that. So it's very easy, kind of step right through. Same with field sizes. You can add any field sizes, either symmetric or asymmetric field sizes. If you're doing if you're doing SRS cones, you can choose circular, and then you can do diameter. But maybe I want to do maybe a 20 by 20 and a 10 by 10 for this set. And then my scan types, all your practical scan types are here. Your in-plane, your cross-plane, your depth measurements. If you're doing diagonals, if you want to get those very large fields, you can set up diagonals. You can do cross-plane and in-plane half scans, and then there's a merge function in the analysis page, which stitches those half scans together very nicely. So that capability is there. So I want to do maybe cross-plane, in-plane, and depth here. You'll see I've added a couple of different things here. It shows up my depths, my central axis offsets, and then my scan mode. So my depths I want to do, let's see, I want to do it on Dmax, I want to do a 10. My CAX offsets, I just want to do along the central axis, but you can add your offsets here, either positive or negative, depending on what direction. If you want to do any offset off-axis measuring, you can do that as well. Then my scan modes, finally, my last one, I can choose for profiles and depths, I can choose step or continuous. And obviously choosing continuous, it changes millimeters per second. Step is just your millimeter resolutions. I can do zones. Right now I have a single zone. The whole resolution of the single zone across the field is going to be 2 millimeters per step size. But I can also set up multiple zones as well. And you can see here, if I want to change my resolution, say I want to have a higher resolution of 1 millimeter or whatever you decide on. In the more critical, the high gradient, the shoulders and the penumbra regions, you can do that accordingly and set those as you see fit. You can change your zone sizes as well for your inner zones and your outer zones. You can choose your overscan distances, either in centimeters or a percentage of your full width, half max values as well. Depths are very similar. You can choose to either step or continuous. You can force a point at Dmax. So if for some reason my path would not have a dwell point at Dmax for measurement, I can force that, and then it will return back to its original path. So you can do that very easily as well. Again, single zones or multiple zones. I can do a higher resolution zone in the Dmax region, and then as I go deeper, I can just use a less fine resolution as I see fit. Set your zone ends, your starts as well. Excuse me. So that's pretty much your scan queue setup. You can see here as I did those 2 energies at 2 depths, 1 energy, 2 field sizes, 2 depths. I have a total scan number of scans in this set at 10. So it kind of gives you that information as well. But you can see now all these are set as complete, and I'm ready to go ahead and save that and move on to my actual scanning. Measurement, very similarly, just got to make sure that these are all blue and ready to go. A nice feature of our water phantom, since it's not used all the time, you can actually set it up in demo mode, and then I can connect and I can initialize, and I can play with it like it is connected to an actual water phantom. Everything here, I've set my detector set. I just need to set my electrometer. I need to maybe turn my bias on. I'll go 300. I want that on my field and my reference. I can zero my electrometer from here. I can set my position accordingly as well. move to a specific position, set my origin here. Here's my locate beam center, which I kind of touched on earlier with the chamber alignment component. So you can check that locate beam center, and that will give you any shifts that are necessary. But as I set these up, now you see these are all blue, and I'm ready to go ahead and scan. So I can go to my Q tab. I can load my Q, and I just did a test queue the other day, so I'll kind of jump on that. And you'll see here that basically the different field sizes are kind of separated by color. So I've got my 40 by 40, my 30 by 30 here. I can normalize at this point to Dmax. So I can go to that position. I can normalize. Now I'm normalized, ready to go. And I can go ahead and run my scan. I can also zero from here. I can restart my scan. And if I start this, you'll see that I get a couple of invalids just because at a 40 by 40 field size, as I go deeper, obviously the water phantom, I'm going to run into some scatter issues and what have you. So I really can't measure that large of a field size at depth just because of the constraints of the tank. So it's just letting me know, but it will run through that. It'll skip those, but it'll keep going for the rest, and it'll show you your active scan in green and the percent complete. And it'll kind of, once that completes, it'll move on to the next one and run through. And then when I get to this point where I need to change my field size, I'll get a notification, and it will notify me that I need to either change my energy or change my field size, whichever the case may be, or both. So that gives you the run through for that. But in the meantime, while this is scanning, I'm going to jump over to my analysis page. And I've got a few scans that I brought in already. We've got all our capabilities here, our different filters. We've got a couple of smoothing filters. We've got a Gaussian and a boxcar smoothing. We've got a couple of, you got the ability to do point edit, a couple different normalization. You can normalize at center. You can normalize to a value. You can center the scan. So if you're offset a little bit, you can actually just click that and it'll center the scan for you. You can do an average symmetric value from the right to the left. You have the ability to mirror from negative to positive or positive to negative. You can do a flip of the scan as well, and then you can also do a shift. So some of the features I kind of mentioned, we did two new updates this year or in 2022. One was in, I think, April, and the other one just came out in December. But you have the ability to select some scans as reference, and basically, if you have some set scans that you want to use as your reference to compare maybe your original scan set, you can set those as your reference scans, and then subsequent scans down the road can be compared to that original reference scan. So I've already set a couple different reference scans for showing here for demo. So I can go ahead and I can show those reference scans. I'll click on this box here. And then basically what you have here, you've got what scans are showing in your scan window. I can bring up those metrics, and you'll see scan ID 70 and scan ID 544. Those are set as my reference scans, and that's noted here by your comparison. They're comparing themselves with themselves. That's why you're seeing asterisk there. But if you're comparing, scan 546 and 690, which is the blue and the yellow, to those reference scans, you'll see what your reference scan values are. Here's your ID, what your full width half max, your center. So you can kind of see those comparisons along the way numerically for those specific metrics, what your max percentage is comparatively, your minimum, your flatness, your symmetry, and your what have you for your different metrics. But then we also have a gamma graph here showing you the gamma scores, and you can change those tolerances both for your dose tolerance and for your distance to agreement. So it's a nice feature to be able to kind of track and see those comparisons of the reference scans to your subsequent more recent scans. So that's kind of some new functionality there. let's see, like I said, you can merge your half scans. You can save different scan sets. So if you have a whole host of scans shown here, you can save those as a scan set. You'll see here now I get this little indicator. This is just telling me that my next scan, active scan, needs to be changed. So I need to change it from my 40 by 40 field to my 30 by 30 field. So I go in, I change my field size at the console. If I go back to my measure page, then you'll see that I can then start my next batch here and move along from there. So I've got now my new active scan going at my 30 by 30. So it kind of gives you, and there's an audible indicator as well, kind of a ding. If I had the volume up, you could hear that as well, just kind of telling you, not only did a dialog box come up saying I need to change something, but you get an audible ding kind of letting you know as well. Back to analyze. So I've got my, like I said, merge half scans. I can add filters accordingly. So any of these filters, if I want to see what filters are applied to specific scans, you can see. I can remove that any last filter. I can clear all my filters to give my, back to my raw information, my raw data. I can look at different scan sets that I have saved, as you see here. My export, this is where I would export to my various treatment planning systems or other DoseView software. So you can see all the most popular, most used scan export treatment planning systems here: Eclipse, Monaco, Pinnacle, RaySearch, RayPlan. We also have now CyberKnife that we added in 2022 for transferring all that to the treatment planning system. We can also export in CSV. We can export convert our depth measurements to PDD tables, and you can also convert those PDD tables to TPR. So that's all capability of functionality there. We have DoseView. So if you want to use the software on another PC, you can export those scans in DoseView format, so you can open it up on another instance of DoseView on a different computer. So that functionality is there as well. You have the ability to import scans. So not only can you import other DoseView scans, like I said, if you export to the DoseView format, we also have a tool that allows you to import data from legacy scanning systems. So if you're an older PTW or an older IBA Phantom, you can convert that scan data and bring it in, so you can kind of compare some of your old scan data to data that was brought in and measured by the DoseView system. And then finally, reports. We've got a couple different reports. We've got the CSV export for the data. You can bring that into a CSV format, so for manipulation and analysis in Excel. Then we also export into an isodose curve PDF, so that capability is there as well. So that's kind of a quick and dirty run through of the software. And like I said, I was a kind of a quick overview. It didn't get too into depth of things, but I wanted to try not to take too much of your time. So just kind of touch on a couple things, as far as our hardware and software system. For the summary of those, the hardware, very structurally rigid design, very repeatable and accurate 0.1 millimeter per axis precision, and quick system setup with the alignment jig capability. You have that wireless functionality for setup ease and time saving. If you want to use it, you can use it in wired mode as well. It's got a fast acquisition dual channel electrometer with that independent bias, and a very intuitive and versatile detector alignment system, like I mentioned, with the number of different detector functionalities and different detector holders included. Software, again, very easy, right to left, or I'm sorry, left to right, top to bottom navigation. Quick queue setup with very easy copy and editing functions. I didn't really touch on that, but that's something maybe if you want to take a look, a little more deeper dive in it, I can show you that in at a future web demo. No hidden features. Everything is kind of at your fingertips. Have the step for continuous scanning with multiple zones that you can choose. Full export to any number of different treatment planning systems and different formats. That import functionality for legacy scan data, again, from PDW or IBA. If you have an older system there, you want to bring data into kind of analyze within the DoseView software and do comparisons there. Very straightforward post-scan processing and metrics. And like I said, we also in 2022 had 2 releases of the software updates. We increased the scan comparison functionality, including adding the gamma analysis, the isodose curve report generation as well, and then the updated the half scan. We kind of updated that half scan merge capability. We kind of improved upon that a little bit to make that a little easier to use as well. So that's kind of the highlights of the DoseView system. I thank everyone for their time.